Hey guys, I'm going to be going over this problem that came up on Tuesday, and I'm hoping to give you a strategy that will help you on any collision problems, any momentum problems that you work on in the future. So we're going to start with something that I've said a bunch of times in the past, which is that the initial momentum is always equal to the final momentum. That means that what we want to find is we want to find the momentum before the collision, and that is going to help us find this guy, which is the momentum after the collision. Great. So the first thing, I'm going to draw a little picture. So I'm going to have sort of a before the collision section. We know before the collision section, we've got this big 60 kilogram cart, and it's moving forwards at 17 meters per second. My pen is dying a little bit. And we can see that there's also this 35 kilogram cart. And that one has a velocity of positive 5 meters per second. So that actually means it's moving the same direction because they're both positive. So 5 meters per second, just like that. Now, since this one is going faster, it's going to eventually catch up and bump into that one. That brings us to our after drawing. In our after drawing, we have the larger cart, so the 60 kilogram cart, 60 kilograms, is moving forwards the same direction at 10 meters per second. And so the question is, this is our 35 kilogram cart, how fast is that going? So like I said, we're interested in the momentum before the collision and the momentum after the collision. So I'm gonna calculate some momentum right here, momentum. And sort of under each cart, I'm going to write what its momentum is. So this one, momentum is mass times velocity. So I'm going to write 60 times 17. This one, mass times velocity, is going to be 35 times 5. And what we can do is we can actually add those together to find the total momentum of the cart. Down here, we're going to do the same thing. Here we have 60 times 10 plus 35 times question mark. We don't know what that is. That's the thing we want to find. So I'm going to quickly plug into my computer 60 times 17 plus 35 times 5. That gets me 1,195. And this one down here, I can't actually solve for a number because it's got a question mark in it, but it's going to be 600 plus 35v, where I'm putting in v to represent that final velocity that we're trying to find. Cool. I'm going to push this up. All right, so now to really find that v, what we know is that the total momentum before, this is momentum before, well, we know that momentum before is equal to the momentum after. So it must be that these two things are actually equal to each other. That gets us, I'm just going to one more time write, because like I said, this is our key equation, is that the momentum before is equal to the momentum afterwards. That means that 1195 must be equal to 600 plus 35v. Now at this point, this is just an algebra problem, but I'm going to go ahead and follow through. So we'll subtract 600 from each side. That's going to get me 595 over here. I hope that that's right. So a little bit of mental math equals 35v. Divide both sides by 35 to find our answer. V equals, I gotta go back to my computer. .595 divided by 35 is 17 meters per second. So in this case, I drew a picture, which I always think is helpful, but really my process was to find the total momentum beforehand and the total momentum afterwards. And even though I wasn't able to find a number there, I was able to find an equation, which is equally helpful. Because then what I did is I set my number equal to my equation, and then I was able to just solve that for the missing variable. I really hope that was helpful. As always, reach out if you have any questions.